Welcome to the video on using sum and difference formulas, but this time given in a particular quadrant. And notice here as a summary, I have all of the sum and difference formulas for sine, cosine, and tangent. During this video, we are mostly going to be focusing on the first two. Tangent is used, as you've seen in previous videos, but not as much in this particular one. So let's get started here on a few examples. Find the sine of u minus v, given that u and v are in quadrant 2. Now what we're going to do is whenever we're not sure how to start a problem, we usually draw some kind of picture. And a lot of the times it helps to draw a triangle because really, again, everything is based on triangles in some way, shape, or form. So if it says that the sine of angle u is in quadrant 2, what I would do is draw a little picture. In quadrant 2, I would draw a little right triangle, and u is going to be my reference angle, which again is from the x-axis up. So this is little angle u, and it tells me that the sine, or opposite over hypotenuse, is 5/13. So if this is angle u, this would have to be 5, this would have to be 13, and because either if we use the Pythagorean theorem or remember this is a 5, 12, 13 triple, this length would have to be 12, but because it's in the second quadrant, the x is negative, so the 12 must be negative. What we would do for this one is draw a separate triangle because we're dealing with a different reference angle this time. So we're still dealing in quadrant 2, so I would draw another little right triangle. This time I would call my reference angle v. I'm given that the cosine, or adjacent over hypotenuse, is 4/5. This negative could apply to either the 4 or the 5, but not both. The reason is, if I had negative over a negative, that would change this ratio to be a positive. So let's decide which one it makes more sense to be negative on. Cosine, adjacent over hypotenuse. Again, because the x is negative, it would make more sense that the negative is on the 4. Using either Pythagorean theorem or triples, this is a 3, 4, 5 triple, and the 3 has to be positive because the y is going upwards. Now that I have this information, I can actually find what I'm looking for. But first, I want to remind you, if I wrote sine of u minus v over here, remember that the sign cannot be distributed. This is not equal to sine of u minus sine of v. If you do that, that is mathematically illegal. What instead we would do is think about what we've been using in the last couple of videos. If I want to find sine of an angle minus an angle, it is the same as sine times cosine minus cosine times sine with the angles reversed. So if I wanted to relate it to this problem, instead of a minus b, we would have sine of u minus v is the same as sine of the first angle u times cosine of the second angle v minus, again the sign stays the same. Now again, instead of cosine sine, how I like to think of it is it's again the same idea except for the angles reversed. So you can think of it as sine of v times cosine of u. I like that better because we have somewhat more of a pattern. And again, remember, cosine times sine is the same as sine times cosine. Doesn't matter what order you multiply in. Now at this point, it may seem like we don't have enough information because in the past we knew what these two angles were, so we could plug them in and use the unit circle. But the reason that we draw the triangles is we can plug in what we know sine of u is. We can plug in what we know this is, then separately this, and then finally this. So let me go color coordination wise. Sine of u, if I look at angle u here, is opposite over hypotenuse. So it is really 5/13. If I find cosine of v, now I'm looking from this reference angle. Cosine is negative 4/5 minus sine of v is 3/5. And lastly, cosine of u is negative 12/13. So even though I did not know specifically what the angles were, I do know what the ratios are. So if we continue with this problem and multiply it through, this would be negative 20/65 minus, well, I have minus a negative, so I'm going to change that to plus 36/65. And now that these have the same denominator, which is quite handy, if I do 36 minus 20, I get 16/65 as my final answer. So for these coordinate problems, you're going to have a ratio as the final answer. Let's do the process again on the second one. Given sine of x is 24/25 and sine of y, a different angle, is 3/5, where x is between 0 and 90 degrees and y is between 90 and 180. What that means to me, if an angle is between 0 and 90, this is really in quadrant 1. And if an angle is between 90 and 180 degrees, it is in quadrant 2. And if you think about that visually, again, if we draw some pictures, if I draw a little coordinate plane, 0 and 90 degrees has to be quadrant 1, which means that my reference angle of x must be here, and sine, or opposite over hypotenuse, is 24/25. This is a 7/24/25 triple. My 7 has to be positive because I'm in the first quadrant. So this is what I gain from this piece of information. This piece of information, if I'm thinking about an angle being between 90 degrees and 180, my triangle has to be in the second quadrant. And so sine is opposite over hypotenuse. So this is a 3, 4, 5 triple, but just like the last problem, this has to be negative because it's in the second quadrant. And so now that I have all of this, I'm going to look at what I need. I want to find cosine of x plus y. And that is not the same as cosine of x plus cosine of y, because I cannot distribute. What I can use instead is this idea. That cosine of, instead of a's and b's, it's cosine of x plus y is equal to cosine of the first angle times cosine of the second angle, y, minus sine of the first angle, sine of the second angle. And again, it seems like I don't have enough information because I don't know what either angle is, but I don't need to know that information because I know my ratios from my triangles. So cosine of x is adjacent over hypotenuse, which is 7/25. Cosine of y, which I should have put a little y here, is going to be -4/5 minus sine of x is opposite over hypotenuse, and sine with the reference angle of y is 3/5. So again, like the last problem, if I multiply this out, I would get -28/125 minus 72/125. And if I combine those like terms, I get -100/125, which can be reduced because I can divide both by, let's see, what could I divide both by? 25. So that would be -4/5. So my final ratio answer is -4/5. Now this last problem I made up for you to try completely on your own. There is a little bit of room in the notes packet in the top corner if you'd like to do this problem here, or you could do on a separate piece of paper. But I gave you that x and y are in the third quadrant. So I would draw both triangles in the third quadrant, given that the ratio for cosine is -5/13 and the ratio for y is, or the tangent of y is 7/24. And your goal is to find the sine of x plus y. So when you're doing that, please make sure to keep these identities in mind. So please pause now and try this problem completely on your own. Before you do so, again, think about the third quadrant. Think about what has to be negative. Does x have to be negative? Does y have to be negative in the third quadrant? That will help you get the answer correct. So please pause now. Okay, so you have to be careful on this problem. Make sure when you have your two pictures in the third quadrant, make sure both your x and y values are negative, because in the third quadrant you're going to the left and down. And make sure that your hypotenuse is always positive, because if you do the Pythagorean theorem, negative squared plus another negative squared has to be a positive number. And also notice that the tangent of y is a positive ratio. That's because you're doing a negative over a negative. So you need to be careful with your signs, S-I-G-N. Now, if you're trying to find the sine of x plus y, that is the same as sine of x, cosine of y, plus the sine of the other angle and the cosine of the other angle. So all of these ratios should be different. The sine of x, I got to be -12/13. Cosine of y, I got to be -24/25. The sine of y, -7/25. And the cosine of x is -5/13. When I multiplied this through, I got 288/325, plus, and it is a plus because I got negative times negative, 35 over 325, which got me a final answer of 323 over 325. So that's the last example in the video. I hope this was useful and we will be practicing this more in class.